Okay, advanced placement calculus. Y'all ready for math? I hope everybody's doing okay out there. Okay, we're going to start with topic-specific review today for the AP exam. I know you looked at that part one. Okay, hopefully you had time to try it out, to take a look at my video solutions. And I know right now you feel discouraged, okay? The AP exam is extremely difficult. Remember, to get maximum score, you'll need to get about 68% of it right. People are like, oh, that's easy. No, that means the exam is extraordinarily difficult. And you guys already as a group, many of you don't have the level of confidence that you should have because you're a lot more intelligent than you give yourselves credit for. But look, don't worry about these things. You do the best you can. Put in your work, put in your work, put in your work. If you put in your work, you will do well in the AP exam. If you don't put in your work, you have no chance, okay? I've seen surefire fives become ones because they don't do anything. Obviously, things are a lot different for you because you could have a different type of AP exam. Try not to worry so much about that, okay? Keep working right now. Let's get into some topic-specific stuff, even though today's going to seem kind of silly, okay? Today we're actually going to be talking about area and volume. Area and volume. Area is indeed on this advanced placement exam, even though they said area between two curves won't be there. But they say volume's not going to be on it, and that's fine. You know what? If you want to skip this video because you only care about the AP exam, fine. But I'm not just going to review stuff that's going to be on your truncated AP exam because a lot of you guys are going to move further into math, and you're going to have to actually get used to and know how to do these problems, okay? So it's important that we review stuff like this. You might notice there was some notes, okay? There were some notes on area and volume. Remember how to get area between two curves, okay? We talked about discs, washers, area, volume by cross-section. We're going to do that today. But the notes are there. It's kind of like a sample problem. And I believe also on the notes is position, velocity, acceleration notes. We'll get to that tomorrow. And that's something that we'll do for 2 days because it could be on your AP exam. And I wouldn't be surprised if you saw a part 2 problem like that. But let's jump in. Area and volume, the little ditto I gave you. Let's take a look at 2005B number 1. On each of these dittos, it'll tell you whether or not you're allowed to use a calculator. Sometimes it'll say calc or no calc in parentheses. Here it's actually written a graphing calculator is required, so you know whether or not to have your calculator. On your AP exam you're going to take, they say you won't need the calculator, but you're allowed to have it near you. I would keep it near me just in case, who knows. So let's actually do some problems. We'll go through 3 today, and you'll have your homework. Do your homework for AP review. Okay, please, take a look at what we're doing in class. Make sure you do your classwork. Okay, also do your homework as well. You gotta get yourself into the AP groove. We'll do a bunch of topic-specific stuff. Eventually, we'll get back to some part 1 problems. Hopefully, you'll feel a little bit more comfortable. 2005 AP. This is Form B. It's actually they always give a Form A and a Form B. They don't release Form B anymore, but they used to. Let f and g be the functions given by f of x is 1 plus sine Twix. They tell you right there. G of x is this guy, e to the x over 2. Let r be the shaded region in the first quadrant, enclosed by 2 graphs as shown in the figure above. And part A, which is part A. They just want you to find the area of R, okay? And look, to get the area between two curves, let's draw that vertical rectangle. We only draw 1, but we really imagine like an infinite amount, or like 7, something like that. You can see throughout the region, f of x is always the upper, g of x is always the lower. So as far as area is concerned, little integral action, okay? Upper function minus lower function, f of x minus g of x, I'll even write it that way, all with respect to x. But of course, we need our bounds here, okay? And that's the time we're going to go to the calculator. Looks like the lower bound is 0. I wouldn't trust it if it's a calculator problem because it could be 0.001. But if it's a non-calculator problem, you'd be able to trust it as 0. This upper bound here, I guess we'll call B. All right, so let's get those calcs rocking and rolling. Radian mode, radian mode, radian mode. Okay, I see trig here. I spy with my little eye. Trig and trig. And that means you all got to be in radian mode. Always radian mode for this class anyway. 1 plus the sine of Twix. So I got f of x in y1, g of x, e to the quantity, alpha y equals phi equals x over 2. All right, I'll zoom 4 here. They don't really give me many parameters. And you'll see a bigger graph than what we actually need. Okay, what we actually need is this right here. There's my little region right there. So you can calculate intersect. It's still working right there. I'll tell you, these new calculators are slower than the yellow ones. hit enter here 3 times. You'll see that lower bound is 0. Okay, so I do want a 0 right here. Upper bound is going to be something nasty and irrational, most likely. Calculate this intersect. Okay, and I get that, oops, as 1.135692535. Okay, so I'm going to say that B is approximately 1.135692535. I'll store it on my paper. I'm going to store it in the calculator as well. Okay, and then the integral from 0 to B. And now I could just get what my answer is. Okay, little math niner. Nothing could be finer. Go out to the diner. Not now. Maybe for takeout. 0 to alpha B. Okay, I got y1 minus y2. Alpha twaithy, alpha twaithy. Y1 minus alpha twaithy, y2 with respect to x. And I get approximately 0.429. I wish there was one like this in your AP because they're usually not too terrible. Newsflash, they can get terrible, but this one right here, not so bad. Good one to start with. Find the volume of the solid generated, part B here, when R is revolved about the x-axis. Oh, 3-dimensional here. That's why we got volume going on. And look, when you revolve about the x-axis, don't forget, always draw a rectangle perpendicular to the axis of revolution. So I'll start right here. Look, I know it's the normal world, right? Because it's a horizontal axis of revolution, vertical rectangle. Don't head downward. There's no region. Head upward. We voluntarily pass in the region. Don't keep going. You never voluntarily pass out. That's good advice. Okay, and you can see that the rectangle is not entirely in the region. That means it's a washer. Okay, big R squared minus little r squared. So we know, I'll put B over here actually so I can see it a little bit better. Just white this out. Hee, white out. Right, like wipe out. Sorry. Okay, so B, find the volume of the solid generated. So volume is equal to, don't forget that pi, right? It's actually a circular cross-section. The cross-section is a circle. So you want to integrate the area of that circle. That's the big R squared minus the little r squared. You know, here, we don't really talk about cross-section when we do 3-dimensional. We have that pi in front. And look, we know the bounds. We know it's the normal world, 0 to B. Remember, big R squared minus little r squared. Big R, I don't want a piece. I want the whole thing, the whole rectangle, and that's y equals f of x minus y equals 0. So that's f of x minus 0, quantity squared, minus little r. Remember, is little r the piece of the rectangle that's snug as a bug in a rug inside the region, or is it the piece that's freezing out in the cold? You're right, freezing out in the cold. It's going to actually form that hole when you revolve this thing. So upper minus lower, whatever y equals, g of x minus 0, that's little r. Let's quantity square that sucker and integrate it all with respect to x. You guys did well in this test. This stuff should come back pretty quickly here. Some people on the test were able to set these up, but then couldn't get the answer in the calculator. So always be careful with stuff like that. Don't forget we need a little pi action here. A little math niner. Integral from 0 up to alpha b. Berto, what you heardo. F of x minus 0 quantity squared. That's y1 minus 0. Quantity squared, you can obviously just say y1 quantity squared if you want to, minus g of x minus 0, that's y2 minus 0, quantity squared, all with respect to x. I hit enter, and I get 4.267 approximately. Okay, remember, you could round or truncate. You'd be good either way. So hopefully that's not too terrible right there. And part C is not horrible either. The region R is the base of a salad. Base of a salad? How would I know what the base of a salad looks like? Yuck, yuck. For this solid, the cross sections perpendicular to the x-axis are semicircles with diameters extending from y equals f of x to y equals g of x. Okay, y equals f of x to y equals g of x. Remember, cross-section, okay? All you got to get is the variable area formula for any given cross-section and integrate that thing. So slicing perpendicular to the x-axis, remember x bounds, this is the normal world, we likey, okay? All these slices right here, they represent diameters of a semicircle. Remember, semicircles rising out of the paper toward you. The amount they rise out is going to change depending on what this diameter actually is. You only need to worry about one slice. I pull out maybe this slice over here. There's our semicircle. And remember, it's going to be the diameter that's actually going from, that's flush in the base. And the diameters are all different. That's why you need some kind of variable measurement for this vertical length right there. That's upper minus lower. So any of these vertical lengths, depending on what x value you're at, it's just f of x minus g of x. And remember, to actually get the area of a semicircle using the diameter, that's 1/8 pi diameter squared. If I were you, I'd have that formula memorized right there. So that means if you actually want the area, that's going to be 1/8 times pi, and the diameter is f of x minus g of x, quantity squared. And that's the thing that we want to integrate, okay? See, right now, that's a two-dimensional cross-section. So if you actually want to make this a slice, you got to put a little dx next to it. Give it a little bit of thickness here. Okay, you give it a little bit of thickness. That thickness right there is really going to be dx. You put a dx right there. It's the volume of a slice, and we integrate that. That's how we get all those volumes added up together. So volume is equal to integral 0 to b, same bounds. Integrate that variable area formula, the area of any given cross-section, 1/8 pi f of x minus g of x, quantity squared with respect to x. So here's the area of the cross-section, here's the volume of a slice, and here's the volume of all the slices added up, okay? So hopefully not too terrible. Hopefully you could recall that. You could pull the 1/8 pi out if you want to. I'll even just do a pi over 8. It's funny because people usually overeat pi, but here pi over 8. Little math 9. Integral from 0 up to alpha b, and then y1 minus y2 quantity squared. Make sure you set up another set of parentheses, inside here. Okay, because they won't let you get outside that other set of parentheses. Did I set up that set of parentheses? No, let me insert. I thought I did. Because they won't let you get outside that original set that they give you. So here's y2, and now we're going to quantity square it. Okay, all with respect to x, and I get an answer of 0.078 approximately. So this one's really not supposed to be too terrible. Okay, a good way to start with area and volume, which once again, they won't have volume on your AP exam, but we're reviewing it anyway. Let's move on to the next problem, 2003. Okay, Form B, number 1. Need a graphing calculator here. This one's slightly different, okay? So we got our calculator over here. I'll turn them off just to save some battery. We got let f be the function given by his polynomial right there. So we know that this guy right here is f. And L is the line 18 minus 3x. Okay, so y equals, I'll say negative 3x plus 18. Now it's in y equals mx plus b form, but it's the same exact thing. Then they tell you L is tangent to the graph of f, and here would be our point of tangency. Let R be the region bounded by the graph of f in the x-axis. So here's R bounded by f in the x-axis. S is the region bounded by, you have the graph of f, you have the line L, and you have the x-axis, so shouldn't be too terrible. Part A is kind of cool. They don't always ask you stuff like this. Show that line L is tangent to the graph of y equals f of x at x equals 3. Some people they already said it was tangent to the graph of f of x. Yeah, but they didn't tell you what the x value was, and now that they're prophesizing that that's x equals 3. It's kind of weird because people are like, how am I going to show this thing as tangent at x equals 3? Well, you could just get the equation of the tangent line, like we haven't done that before, to f of x at x equals 3, and it should end up being negative 3x plus 18. Let's try that. Get the equation of the tangent line. First, we need the slope of the tangent line. Slope of the tangent line. Take the derivative. Remember, we want to show L is tangent to f, so we'll take the derivative of f. He's the original. We get 8x minus 3x squared. Okay, and let's evaluate the derivative of x equals 3. So f prime of 3. 8 times 3 is 24, minus 3 times 3 squared, 3 times 9 is 27, so we get negative 3. That's the slope y'all are looking for, which is pretty tight because I get that slope of negative 3 right there. Okay, so that's kind of nice. Let's just make sure the y-intercept is positive 18. Second, let's get b. Plug in a y equals mx plus b. Replace everything but the b. Ow, stung me. We know that m is negative 3. We know x is 3, and to get what y is, plug back into the original, so f of 3 is going to be what? 4 times 3 squared minus 3 times 3. 3 cubed. And you have a calculator anyway. You could use it here if you want to. 4 times 3 squared, 4 times 9 is giving me 36 minus 27. So 36 minus 27, what is that? Negative 9? Negative 9. 9 equal to negative 9 plus b. Ooh, 36 minus 27, positive 9. Sorry about that. What do I know? Okay, and you'll see if you add 9 to both sides, you get that b is equal to 18. So you actually see that y is equal to negative 3x plus 18. Thus, L is tangent to f at x equals 3, okay? Because you showed the equation of the tangent line is the equation of that line that was actually tangent. Sorry, I was writing that and you weren't able to actually see what it was. So a little weird there. Not a type of problem you're always going to see, but something that was kind of cute to play around with there. If you take a look at part B, it's a little bit more the norm. We got to find the area of S. It's more difficult than you might think, okay, as far as finding the area of S. There's a couple different ways to do it. You could get the area of this big right triangle and then subtract from it the area of this portion right here. That works. It's probably in the solution. I'll do it a different way. I'll try to do upper minus lower. You know, the problem with upper minus lower to get the area of S is when you draw that rectangle, here you can see the upper is going to be L and the lower is going to be F. But right here, when you cross over and draw another rectangle, when you cross over that X value, which is the X value of the 0 right there, which we can get easily with the calculator, you'll see that now the upper is L and the lower is Y equals 0. So you can still use upper minus lower. It's just that you need two separate integrals, right? So it's not really too terrible. I'll do it that way. Say area is equal to, first integral is actually going to go from 3 up to this 0. So if you're not sure what it is, okay, you could easily graph y equals, what was f of x? 4x squared minus x cubed. So 4x squared minus x cubed. I don't know if Zoom 4 is going to cut it here. We'll see. It does. There's the 0. It's at 4, you know, if you don't believe me, which you shouldn't, okay? It's the calculator. You should always make sure you calculate these things. You can't guesstimate unless it's a non-calculator problem. But you'll see that that 0 is actually 4 right there. Okay, so here's next value, 4. So my first integral is going to go from 3 to 4. And then I'm going to do upper minus lower, so 18 minus 3x minus my lower function, which is f of x. You could even put f of x, all with respect to x. Don't be squaring it or anything like that, okay? It's just area. Plus, now my other integral, we're going to calculate from 4 up to this 0, which you can get by setting y equals 0. You can use the calculator, obviously, if you want to, but you can see if x is equal to 6, that y equals 0 here. So the integral from 4 to 6, pick up where this one left off, right? Upper minus lower, that's L, which is 18 minus 3x minus 0 with respect to x. And that's my setup right there. Let's get a little calculator work going here. Maybe I want to put in y2, 18 minus 3x, so it's easier to put this stuff in the calculator. Okay, so two integrals here, math 9. First one, 3 up to 4. My kids are screaming. 18 minus 3x, that's y2, right? Oops, I'm hitting second trace. I want alpha trace, y2 minus y1. Okay, that's f of x right there with respect to x. Let's add to that another integral, this one from 4 to 6. And now we have of just y2 minus 0, right? I'm going to put in the y minus 0 with respect to x. Hit enter. I get 7.917 approximately, which is hopefully what you get as well. So other ways to do it, you'll see in the homework, but it's not really as bad as you might think. So please don't be afraid of something like that. Part C is cool. We want to find the volume of the solid generated when R is revolved around the x-axis. Hey, draw that rectangle perpendicular to the axis of revolution, vertical axis of revolution, which means the rectangle is going to be horizontal axis of revolution, which means the rectangle is going to be vertical. What do I know? And when you start here, the second you head upward, you're in the region. Don't pass out, go to the extreme of the region, bring it back. That actually makes it a disk, okay? It's not actually a washer here. So volume is equal to pi times the integral. Just remember the region F here goes from 0 up to 4. So my integral is going to be from 0 up to 4 over here. And look, it's just a disk. It's just upper minus lower quantity squared. This rectangle is going to create a radius. When you revolve it around, the radius of a cylinder, we're just getting the volume of a cylinder, pi r squared h, and we're integrating it. So you can see upper minus lower is f of x minus 0, quantity squared, with respect to x, okay? And this right here, that's just pi r squared h. That's all it is, okay? Your height is really the difference of the x values. You can think about it as cross-section. The cross-section, whenever you revolve 360 degrees, is going to be a circle. Remember, we integrate the area of that cross-section. There's the area of the cross-section, pi r squared. Give it a little bit of thickness with the dx. That gives you the volume of a slice, and then we get all those slices, add up their volumes. That's why we integrate. Okay, so set up my little integral here, little pi action, little math niner, math 9. Integral from 0 to 4. F of x minus 0, quantity squared. So that's going to be y1 minus 0. Quantity square that sucker. And I get Mr. Harrington's age, 490.208. Okay, he has lived an extraordinarily amount of time. That's why I think he's really a robot. Anyway, something we'll discuss when I'm allowed to discuss something like that. Jedi Council doesn't like me to discuss droids. Anyway, so there's my answer for that problem right there. Sorry, going off on a little bit of a tangent there, but it's totally apt in a calculus class. So hopefully not too terrible. Okay, remember, we're not going to focus really on this on the AP. We're going to go through another part 1. We're done with part 2s. Then we're going to kind of focus on what I predict, is going to be on the AP that last week. We'll kind of get that focus going right there. I think it'll be like 8 days. That's a lot of time. Or maybe less, or maybe more. I don't know. But let's try another problem here. Okay, 2009, number 4. And 2009, this is actually number 4 right here. So that meant that you didn't have a calculator. So we're going to put them away. No, I need to help you. No, you're going to... Let's put the calculator over there, okay? Just kidding. That was mean. Sorry, calculator. It's okay. So anyway, no calculator here. Let's try this 2009 problem. Let's rock. Let's roll. This is math we had to control. Ow! Hey, let R be the region of the first quadrant closed by the graph of y equals 2x. It's supposed to be this right here. Sorry, the concavity is all wonky because of the copy machine. Or my printer really is the problem, but whatever. That's y equals 2x right there. We didn't have a calculator. How are we supposed to know that? Because that's the linear. And then y equals x squared, we could see is right here. All right, so here's our y equals x squared, the quadratic. It's a quadratic. Find the area of R. Shouldn't be a big deal. Upper minus lower action. I could probably fit it over here for part A, which is a part A. I'd flash the lights, but then I have to run up the stairs. Anyway, so finding the area of R, we know area is equal to little integral action. It's going to be upper minus lower. You can see that the upper is always the linear, the lower is always the quadratic. So we know x bounds. You can even guesstimate because it's a non-calculator question, but you can see x is equal to 2 here. So integral from 0 to 2, upper function 2x minus lower function x squared. And then really easy without a calculator here. That's somebody's derivative in there. Who do you take the derivative of to get 2x? X squared. Minus integrate x squared, get x cubed over 3. Evaluated all of it, okay, from 0 to 2. Plug in the 2 first. 2 squared is 4. Minus 2 cubed over 3. We get what I did on Thanksgiving, 8/3. Minus, we love 0 is a bound here. And here's what we love even more. Circle it. You're done. People are like, but I want to get what the value is. You can if you want, okay? Turn that 4 into a 12/3 if you want to. And then you can see that 4/3 is the answer. Not difficult to get. And if you look at my answers, you'll see it there. But part 2 on the AP exam, you do not need to simplify. The second you get to a place where all you need to do is evaluate to compute, you're going to circle that answer right there. You want to save time. It's a little bit different for your AP this year, but essentially still, okay, don't waste time evaluating your answers. If you make a mistake, you're going to lose points. Take a look at B. This is kind of cool. The region R is the base of a solid. Spell cross-section. For this solid, at each x, the cross-section, there's that cross-section, perpendicular to the x-axis, x bounds, it's the normal world. You like calculus, I love it. Has area, what the heck? A of x equals sine pi over 2x, find the volume of the solid. You might remember a truncated version of this problem, on your volume test, okay? They don't tell you what shape the cross-section is. People want to start slicing perpendicular to the x-axis. Yeah, you could do that, but you have no idea what that slice represents. You don't know what the shape is. People are like, how am I supposed to get volume by cross-section if I don't know what the shape is? Remember, volume by cross-section, you just need to get a variable area formula for any given cross-section and integrate that. Well, guess what they gave us? The variable area formula, okay? I don't know what the shape is. I don't care what the shape is. That's the area of any given cross-section. Part B. Volume is equal to integral x bounds, so still 0 to 2. Integrate that variable area formula. I don't care what the shape is. I'm going to integrate this right here with respect to x. A little annoying. Mental integration is great here. You can realize that when you actually integrate sine, in a world of integrals, sine is the bad guy. You know you're going to get negative cosine. Okay, pi over 2x, function means nothing without its argument. But then you're supposed to divide by the derivative of the inside. The derivative of pi over 2x is pi over 2. If you divide by pi over 2, same thing as multiplying by 2 over pi. Some people are like, what the heck did you just do? Evaluate it from 0 to 2. Nothing wrong with a u substitution here. Set u equal to pi over 2x. That means du over the derivative of u is going to be equal to dx. So du over pi over 2 is going to be equal to dx. Only Sabrina would divide by pi over 2, or Ryan Booty. Let's multiply by 2 over pi instead. And that's where the 2 over pi actually came from, okay, when you actually integrate. So if you do it this way, then it becomes the integral. Got to change those bounds, right? Instead of saying from 0 to 2, well, if x is 0, we know u is equal to pi over 2 times 0, which is 0. And if x is 2, u is equal to pi over 2 times 2, which is just pi. Then we have sine u, c do, times du over pi over 2, so 2 over pi du. Pull that 2 over pi out to the side. Integrate sine u with respect to u, and we get negative cosine u. Evaluate it from 0 to pi, which means now we're going to end up with negative 2 over pi cosine u evaluated from 0 to pi, which is the same thing as this over here. Okay, right now if you put in the 2, you get negative 2 over pi cosine of pi. That's what's going to happen here. When you plug in the 0, negative 2 over pi cosine of 0, which is what is going to happen here, okay? So this is probably easier, the u substitution, but you could do this as well. Either way, all right, I get the cosine of pi minus the cosine of 0, which, by the way, we're going to stop right there because that's the answer. It's not necessary to actually, evaluate it. I mean, you should know the cosine of pi is negative 1 minus the cosine of 0, which is going to be equal to positive 1. Why am I putting a 0? I have no idea. Okay, so really it's just negative 2 over pi times negative 2, which gives you 4 over pi for the answer. But you can stop right here, okay? The second you only have to evaluate, even trig evaluation, you can stop. One year we plugged in, we ended up with like the sine of negative 1. People are like, how the heck do I get the answer? Calculating the sine of negative 1 radian by hand is extraordinarily difficult, okay? Not something we're actually going to do here. So look, make sure that the second you plug in, just stop right there. We still got a part C here, another solid. Another solid is getting out of hand. Now there are 2 of them. Come on, prequel meme. Another solid has the same base R, so the same base right here. For this solid, cross-section is perpendicular to the y-axis. Oh no, y bounds. It's the bizarro world, the opposite of everything that ever was. Okay, so you're like, oh, I hate calculus, because that's the opposite of the way you normally feel. And they tell you the cross-sections are squares. Right, and then the greatest phrase in the history of mathematics, but do not evaluate, an integral expression for the volume of the solid. I'll do it over here if you don't mind, part C. Okay, and look, now they told you what the solid was. They told you it was a square, but now you're slicing perpendicular to the y-axis. Okay, so each of these right here, each of these slices represents the side of a square. Pull one of those slices out, pull one of those squares out. Okay, and this little squiggly line right here really represents this, okay? And this distance, well, that's going to be different, okay, depending on what y value you're at. That's why you need a variable horizontal length, and that's right minus left. And the right function is not x squared. Remember, you don't want what y is equal to. You want what x is equal to, so take the square root of both sides. People like positive and negative square root. Well, we're dealing with x here. X exists to the right of the origin here, so that's why you want the positive square root. And here, if you solve for y, you solve for x, y over 2 is equal to x. So the right minus left, you want whatever x is equal to, okay? I don't think you can see that in the EP, which might probably fills you with tears of joy. But anyway, we'll talk about it. Right function, you can see is radical y minus the left function, which we know is y over 2. So that's the side of a square. How do we get the area of a square? We square a side. And that's the variable area formula. That's what we want to integrate. So we can say volume is equal to the integral, y bounds, right? Are you guys on your toes? Bizarro world. We'll go from 0 to 4 here. Okay, and now just take that variable area formula, radical y minus y over 2 quantity squared, and integrate it with respect to y. Okay, that would be my answer right there. And all we got to do is write, but do not evaluate. So really, area and volume, not too terrible. not supposed to be on your AP, volume anyway, and they say area between two curves is not. I'll scan that document with a fine-tooth comb, and we'll have more information about that as we get close to the AP, and we'll be more succinct and focus more on that stuff. But really, it's important for you to know as well, okay? A lot of you guys could be taking Calc 2 next year. This is huge, okay? Knowing these things, it's really going to help you out. So I hope that was all right there. First day of topic-specific review. Keep working, keep working, keep working, keep working. If you keep working, you succeed. If you don't, you will not succeed. Trust me. But I've been getting hundreds all year. I know what I'm doing. You're going to get a 1. I've seen it happen before. Keep putting in your work. I hope everybody is safe and healthy. That's the most important thing. So if you're like, you know what, I have work, okay, but I have things going on with my family, that's okay. Okay, family is the priority here. Do not feel like this is going to ruin your life. Okay, if you're not focusing on calculus right now, but if you're lazy and you're not doing anything, that's a problem. Okay, but if you have other things going on, I understand. Okay, shoot me an email, shoot me a reminder. Let's talk about it if you want to. We'll get through this together. Will I see you guys before the end of the year? I sure hope so, okay? I miss you guys. I do. I don't know if you miss me too. Probably not. Just kidding. But really, I do hope to see you guys again before the end of the year. Maybe that will happen. But regardless, before the AP exam, I don't think it's very likely. So do the best you can. And like I said, if you have any questions, let me know. And please, these videos, I've been getting feedback. For the most part, people tell me they're good. But please let me know if I could do anything better. And that's about it. Berto signing off. See y'all later.